Hello students, in this video in a bank, principal increases continuously at the rate of 5% per year. An amount of rupees 1000 is deposited with this bank. How much will it worth after 10 years? So again, principal increases at the rate. So rate of change of P. So P, take it as the principal. dP with respect to time. So dP by dt is 5 by 100 of P. The rate is given 5% per year. So it is 5 by 100 of P. So we have this equation. So let us separate the variables. So dP by P is 5 by 100 into dt. Now integrate this. So when you integrate, you will get log P is 5 by 100 T plus the constant C. How do you find the constant C? So an amount of rupees 1000 is deposited. So that means initially, that is when T is 0, P is 1000. Okay, initial amount is 1000. How much will it worth after 10 years? So when T is 10, what is the amount? That's the question. So we have this constant. Let us find the constant C now. Put T is 0. P is 1000. So log 1000 is, this is 0. C is log 1000. So this equation becomes log P is 1 by 20 T plus log 1000. Now the question is, after 10 years, when T is 10, what is P? That's the question here. So what do you do now? Put T is 10. So when T is 10, so what happens here? Log P is 10 by 20 plus log 1000. So log P minus log 1000 is 1 by 2. That is log P by 1000. Use the quotient rule here. So log P by 1000 is 1 by 2. So that means P by 1000. So log, you can change it to exponential. Take it to the other side, it will become exponential. So e power 1 by 2. P by 1000 is e power 1 by 2. I think e power 1 by 2 value is given. E power 1 by 2 is nothing but e power 0.5. That is 1.648. So P is 1.648 into 1000. So P is 1648. So that's the answer. After 10 years, P will be 1648. In a culture, the bacteria count is 1 lakh. The number is increased by 10% in 2 hours. So 10% of this is increased. It is increased by 10% in 2 hours. How many hours will the count reach 2 lakhs if the rate of growth of bacteria is proportional to the number present? So rate of growth of the bacteria when T is 0, initial count, the bacteria, the count is 1 lakh. When T is 2, after 2 hours, the count is 10% of this 1 lakh. Number is increased by 10%. So 10 by 100 of 1 lakh plus that 1 lakh. 1 lakh with that 1 lakh you have to add this 10%. So 10% of this is 10,000. So it will become 1 lakh 10,000. So when T is 0, the bacteria count is 1 lakh. When T is 2, the bacteria count is 1 lakh 10,000. So when the count is 2 lakhs, how many hours it will take? That's the question. How many hours will it take to reach the count 2 lakhs? And what is the condition given? The rate of growth of bacteria. So B is the count of the bacteria given. Rate of growth. Whenever we say rate of growth, we just use differentiation here with respect to time. So dB by dt, rate of growth of bacteria is directly proportional, is proportional. So we take it as directly proportional to the number present. So dB by dt is proportional to B. So dB by dt is, whenever there is a proportional sign, we replace it by the constant k, take it as k. Now let us integrate this and find B. Separate the variables. So dB by B is k into dt. So integrate this. So we will get log B is kt plus C. Now there are two constants. So let us use the two conditions given. So let us use the first condition. T is 0, B is 1 lakh. So put T is 0, you will get log 1 lakh is C. So that means the equation 1 becomes log B is kt plus log 1 lakh. Now, to find the second constant, how do you find the second constant? That is this constant k. The second condition, T is 2, the bacteria count is 1 lakh 10,000. So put T is 2 and bacteria B is 1 lakh 10,000. So log B will become log 1 lakh 10,000. T is 2, so 2k plus log 1 lakh. So bring this 1 lakh this side. Log 1 lakh 10,000 minus log 1 lakh is equal to 2k. So use the quotient rule here. So log 1 lakh 10,000 divided by 1 lakh is 2k. So that means k is equal to, bring the 2 here, 1 by 2 log 11 by 10. Okay. So second equation is log B is equal to k. K we got it as 1 by 2 log 11 by 10 into T plus log 1 lakh. The question is, when the bacteria count is 2 lakhs, the time taken, how much time it will take for the count to reach 2 lakh. So when B is 2 lakhs, when B is 2 lakh, what is T? That's the question here. The time taken is asked. To put B is 2 lakh, so log 2 lakhs is 1 by 2 log 11 by 10 into T plus log 1 lakh. So bring this log 1 lakh this side. So log 2 lakhs minus log 1 lakh. There is division. is 1 by 2 log 11 by 10 into t. So this is the quotient rule. So log 2 lakhs divided by 1 lakh. So this is equal to half log 11 by 10 into t. Log 2 is 1 by 2 log 11 by 10 t. Take the 2 that side. So 2 log 2 is log 11 by 10 t. So t is equal to, we want t, isn't it? T is equal to, you can write log 2 square or 2 log 2 divided by log 11 by 10. The general solution of the differential equation dy by dx is equal to e power x plus y. This is e power x into e power y. Now separate the variables. So dy by e power y, e power x dx. So this is e power minus y dy integral e power x dx. E power minus y is minus e power minus y. This is e power x plus c. So that is e power x plus e power minus y plus c. So that's the answer. E power x plus e power, this is the answer. Okay, this is minus c. If you take the other side, it will become c only. This is c only, the constant. So the option A is the answer. The next is homogeneous differential equation. First, you should know what is a homogeneous function. Suppose that they given so many examples here. Y square plus 2xy. Sometimes you can easily identify. See, the degree of this term is 2. The degree of x and y together, it is 1 here, 1 here. So together it is 2. So the degree is the same everywhere. Then it is a homogeneous function. But sometimes we cannot check. So there is a method to check whether the function is homogeneous or not. That is, you put f of xy. If there are 2 variables, put the variables xy here. There are 3, put 3 variables here. So y square plus 2xy. Now put f of lambda x, lambda y. Replace x and y by lambda x, lambda y. So this will become lambda square y square. Okay, y is lambda y plus 2 lambda x, lambda y. So we get lambda square into y square plus 2xy. So that means this is lambda square into f of xy itself. So this is possible only for a homogeneous equation. So we say this is a homogeneous function of degree to this. This is a degree. This is a homogeneous function of degree 2. If it is not a homogeneous equation, suppose if it is y cube plus 2xy, we cannot take the lambda outside because it will become lambda cube y cube plus 2 lambda x, lambda y. So we can take lambda square outside, but one lambda will be there plus 2xy. So this is not f of xy. Okay. So only if it is a homogeneous equation, we can take out that lambda and we can find the degree of the homogeneous function. So if you see here, 4 examples they have given, all these are homogeneous except the last one. The fourth one is not a homogeneous. It looks like, see, the first one is homogeneous, second also is homogeneous, the third also is homogeneous. If you put lambda, you can take it out, but this looks like a homogeneous. Degree is 1, degree is 1. No, but when you put lambda here, lambda we cannot take it out. So this is not a homogeneous function. So that is how you check whether the function is homogeneous or not. So here you can see the last one is not a homogeneous function. Now the other way of writing the homogeneous functions is, see, f of xy is lambda square 2xy. Now if it is a homogeneous equation, the degree is 2, right? So divide both the terms by either y square or x square. So if I divide by y square, I multiply also by y square. So what happens here? This will become 1. I am dividing by y square. This will become 2x, 1y get cancelled. 2x by y. So this is nothing but y square into some function of x by y. If it is a homogeneous function, we can always write like this. If it is not a homogeneous function, we cannot write like that. Similarly, instead of y square, you can take x square also outside. So divide by x square, it will become y square by x square plus 2y by x. So this is x square into some function g of a function in y by x. So if it is a homogeneous function, we can write like this. The degree is 2. Here the degree is 2. Here the degree is 1. So that's what he has given here. That is another way of writing it. See, the same question they have taken here. X square, y square plus 2xy. The function is y square plus 2xy. They divided by x square. So if it is x square, you will get a function in y by x. If you divide by y square, you will get a function in xy. Similarly, they have done for all the sums. But if it is not a homogeneous, we cannot write like that. We are not able to write like y by x or x by y. Okay. So this is about the homogeneous function. Now, when will you say a differential equation is a homogeneous differential equation? The function that you get on the right side. See, we get dy by dx is equal to some function, isn't it? Some function. That function is a homogeneous function of degree 0. This function should be a homogeneous function of degree 0. For example, dy, this is the differential equation, dy by dx, I just write it as x square plus y square by, I'll write this. Now is f of xy. That is x square plus y square by x into y. So how do you check if there is a homogeneous function? Put lambda x, lambda y. This will become lambda square x square plus lambda square y square by lambda x, lambda y. So we get lambda square into x square plus y square by lambda square into xy. This get cancelled. So that means this is nothing but your f of xy itself. Okay, this is lambda past 0 now. So f of, if you can write a function like this, f of lambda x, lambda y is equal to f of lambda past 0. That means the degree should be 0. Both should get cancelled. So then we say this is a homogeneous differential equation. So just see the definition of a differential equation, of a homogeneous differential equation. Dy by dx is equal to f of xy is said to be a homogeneous if this is a homogeneous function of degree 0. Then we say it is a homogeneous. Now, how do you solve a homogeneous differential equation? There are various steps in that. You have to replace y as v into x. All the homogeneous, once you identify them as homogeneous equation, this is how you should proceed. So you make it as variable separable form. To make it in that form, or to bring it in that form, this y, you have to substitute y is equal to vx. Before that, you have to prove that given equation is a homogeneous differential equation.